Sir, Kashinath sir,
Yes, ma'am.
the file is with Javed sir number, sir. I can even share to you. But if he has any trouble, kindly share the screen, sir.
Okay, madam. Okay. Start, madam. Start the class.
Okay, right. Okay, good morning, students. This is Trice webinar classes. So, Parabola class 3 we are discussing now. So, previously we discussed what is the conic section, what are they, and what are the properties, and how they behave. So, firstly, what is the conic section? Conic section is nothing but a double knobbed cone is cutting with a plane, then it will forms 4 types. So that is mainly 8 types, I think. So this is here we are discussing only 4 types, that is circle, parabola, ellipse, hyperbola. So in this one, so we are discussed parabolas, so about parabola and the parabola equations, various types of parabola, and then solved some problems. So now we can solve, now we can choose this one. Now we can discuss focal distance. So focal distance, the distance of a point on the parabola, the distance of a point on the parabola from its focus, focus is called focal distance. What is saying that the distance of a point on the parabola, if we are taking p lies on the parabola, and distance between the focus to that point is called as the focal distance. If px comma y is a point on the parabola, y square equal 4x, whose focus is s a comma 0. We are taking focus as a comma 0. Then focal distance is sp equal to pm. So why we can take sp equal to pm? Here e equal to 1. Why? Because of it is a parabola. So then sp equal to pm. Please observe here. So here pm is parallel to nz. pm is parallel to nz. pm is parallel to nz. So here the value of, I'm writing here, so these values nz, pm equal to nz, and na plus az, I'm writing nz as, I'm writing nz as na plus az, na plus az, I'm writing na plus az. What is the length of na? That is distance between the a and n, and the p lies on the parabola, that is the distance of x coordinate, that is nothing but x1, and az is nothing but a. So that's why the focal distance is, x1 plus a. So once again I'm repeating, focal distance is nothing but distance between focus to a point lies on the parabola. That is the focal distance of the respective parabola. So that is nothing but x1 plus a. Focal distance is nothing but x1 plus a. Okay. So next, so we have to go solve one problem here. Find the coordinates of the point on the parabola y square equal to 8x, whose focal distance is 10. What is asking that? Find the coordinates. That is nothing but the point of p point. So just we have to find the point p. So which lies on the y square equal to 8x, and whose focal distance is 10. That is, observe this figure. Okay, here equation of the parabola is y square equal to 8x. So here this value s is 2 comma 0 we'll find. So px comma y, so we have to find the px comma y, and we know the value of distance between the s and p is 10. So then, so equation of the parabola, so equation of the parabola is y square equal to 8x, then we are compare with the y square equal 4x, we are comparing with y square equal 4x, then 4a equal to 8, we'll get 4a equal to 8, then we'll get a equal to 2. then you will get a equal to 2. A is nothing but the focus. Yes, a is nothing but the value of value in the focus, that is s a comma 0. We are taking s a comma 0 is the focus for y square equal 4ax. We are taking s a comma 0 in y square equal 4ax, that is the focus. Then 2 comma 0, and we have to find the p x comma y. Then the distance between those two s and p is nothing but 10, is nothing but 10. So what is the distance formula? X1 minus x2 whole square plus y1 minus y2 whole square is under root. So that is nothing but sp equal to under root of x1 minus x2 whole square plus y1 minus y2 whole square. Then so s is nothing but 2 comma 0, and let p be any point in the parabola. Now just so first we have to do, then similar we know the formula of distance formula, so we have to solve with the distance formula. And but this is called as a focal curve, focal distance. Focal distance means we already proved x1 plus a is the focal distance with respect to parabola. So that's why I'm doing that. X plus a equal to 10. What is given? That x plus a equal to 10. X plus a equal to 10. Then x plus 2 equal to plus or minus 10. Actually, this is mod of x plus a. So mod of x plus a equal to 10. Then x plus 2 equal to plus or minus 10. Then x equal to, just solve the values for x. X equal to, you will get plus 8. If you're taking to right side 2 value, you will get minus 2. If you take the plus 10, 10 minus 2 is 8. If you take the minus 10, you will get minus 12. This is the coordinates of the p. So which is x value is 8 or minus 12, and y value is, sorry, so y value is, just substitute the this value. Y square equal to 8x, y square equal to 8x, y square equal to 8x means y square equal to 64, y square equal 64, y square equal 64. Then y equal to plus or minus 8, y equal to plus or minus 8. If you substitute the y square equal to minus 12, then you will get, this is the imaginary value, this is a imaginary value. You cannot take the y value, I mean x value as negative minus 12. Then x equal to 8 is the only positive value, and x value is 8 comma 8 plus or minus 8, this value. So p x comma y, p x 8 comma plus or minus 8. So you will get p value 8 comma plus or minus 8. Then next problem. So find the coordinates of the points on the parabola. Same problem, y square equal 4x, whose focal distance is 5/2. This is a repeated question in IP intermediate. So then find the coordinates of the points on the parabola y square equal 2x, whose focal distance is nothing but x1 plus a. X1 plus a equal to, he given that 5/2, and y square equal 2x. From the y square equal 2x, you can get 4a is 2. 4a is 2. 4a equal to 2 means a equal to 1/2, and the focal distance x1 plus a equal to 5/2 given that. So solution, p of x comma y be a point on the parabola y square equal 2x, whose focal distance is 5/2, and then y square equal to x, and focal distance is x1 plus a. So x plus a equal to, given that 5/2, I'm writing x plus 1/2. Here a value is 1/2, and then solve for x. You will get x equal to 5/2 minus 1/2. You have to take 1/2 to right side, then you will get 5/2 minus 1/2. Then you will get x equal to 4/2. Then x equal to 2. So x equal to 2. We have to find the values. Then y square equal to 2 of 2. That is nothing but 4. Y square equal to 4. Then y will get plus or minus 2. You will get y value plus or minus 2. Then the coordinates are 2 plus or minus 2. 2 plus or minus 2. This is the finding the focal distance formula for given parabola. So these two are focal distance. So now, so parabola and a point in the plane of the parabola. So in the previous classes, circles, we are discussed what that a point with respect to circle, a point lies with respect to circle is nothing but inside of the circle, on the circle, outside of the circle. So a circle which divides the plane, into mainly into two types. So that is interior and exterior, as well as here a parabola. Here a parabola also divide the plane with same two types, that is interior and exterior. So which is interior, which is exterior? This is the open curve. So which is having the focus is called the interior part, other one is exterior. See here, so this is the exterior and interior sides, and the parabola red line is there now, so that is on the line, So a parabola divides the plane into two disjoint parts. One containing the focus is called the interior part of the parabola, and other is called a exterior of the parabola. So now, so note for this one, if a point px1 comma y1 be a point, I'm taking any point px1 comma y1, so on the parabola y square equal 4x, which is indicating s is equal to y square minus 4x as per the notations. So then, so P lies on the parabola. If the P lies on the parabola, you will get S11 equal to 0. If P lies on the parabola, you will get S11 equal to 0. If P lies inside the parabola, that is S11 is less than 0. If P lies inside the parabola, that is S11 is less than 0. So P lies outside of the parabola, then S11 greater than 0, which means just you have to substitute the given point in the parabola equation. You will get, if it's 0, that is lies on the parabola. If greater than 0, it is the exterior of the parabola. If less than 0, it is the interior of the parabola. That is the main concept. And these are the notations. No, sorry. So now find the position. So now related problem for that one. So the find the position interior, exterior on of the parabola points with the respective of the parabola y square equal to 6x. Y square equal 6x. Just you have to substitute the first single values. So P, he given that P6, first one P6 comma minus 6, and second one 0 comma 1, third one 2 comma 3. Just you have to substitute the values. So y s equal to y square minus 6x. So then, so 6 minus 6. So this value is s11 equal to minus 6 square. Just to value, y value is minus 6 is in first one. So then minus 6 square minus 6 into 6 is nothing but 36 minus 36 is nothing but 0. So s11 having the 0, which means it lies on the parabola. So now this is 6 comma minus 6 lies on the parabola, given parabola. So 0 comma 1. So just substitute the values. So S1 1 equal to 1 square minus 6 0 equal to 1 is greater than 0. Then this value is greater than 0, which means this is outside of the parabola. So if you substitute the 2 comma 3, you will get less than 0. So as usually, so 3 square minus 6 into 2 is nothing but 9 minus 12 is equal to minus 3 is less than 0. This is the inside of the parabola. This is the finding the where the point lies in the plane with respect to the parabola. So next, so notations. So in the previous problem we take that one notations, and also circles we are taking that one s1 tangent equation power of a point. That's why, so we are also taking here s equal to s identically y square minus 4x, and s1 is identically y1 minus 2a of x plus x1. So how can we get this one? So as per the tangent formula in the circles, so y1 minus 2a of x plus x1. Similarly, s11 is nothing but just you have to substitute the x as x1, y as y1. So then you will get y1 square minus 4ax1 and then 1 2. So you have to substitute as s11. So s11, then you will get one point is x1 comma y1 and the other point is x2 comma y2. So then y1 y2 minus 2a of x1 plus x2, y1 y2 minus 2a of x1 plus x2. So x1 x2 and x1 y1 and x2 y2 are the points in the parabola of the, then y square equal to 4x. This is the notations. So by observing various forms of parabola equations, we may conclude that equation of the parabola. So equation of the parabola. So by observing various forms of parabola equations, we may conclude that the equation of parabola, so whose axis is parallel to x-axis, then we can write that one as x equal to ly square plus my plus n equal to 0. So ly square plus my plus n equal to 0. If it is parallel to x, means x equal to, so this is parallel to x means we are saying x equal to something k. So as usually, so here x equal to ly square plus my plus n, and the next one is whose axis is parallel to y-axis, y equal to lx square plus mx plus n, y equal to lx square plus mx plus n. Then where L, M, N are real numbers, we are taking where L, M, N are real numbers, and L should not be 0. L should not be 0. So we have to solve the one problem on this one. So find the equation of the parabola passing through the points and having its axis is parallel to x-axis. So these given points are minus 1 comma 2, 1 comma minus 1, and 2 comma 1. So just these 3 points lies on the parabola. So lies on the parabola. So then I'm taking, so which is parallel to x-axis. Which is parallel to x-axis means in the previous discussed that x equal to ly square plus my plus n equal to n. So this is the equation number 1. So this is, you have to substitute these 3 points in the equation number 1. You will get, so 1 passes through the given 3 points. Equation number 1 passes through the given 3 points, so that are minus 1 by 2, minus 1 comma 2, 1 comma minus 1, and 2 comma 1. Next, so then if a point passing through the 1, minus 1 equal to L of 2 square plus m of 2 plus n, that is equal to minus 1 equal to 4L plus 2m plus n equal to, this is equation number 2. So then similarly you can solve this b1 comma minus 1, 1 equal to L of minus 1 square plus m of minus 1 plus n, then 1 equal to, you will get L minus m plus n. This is equation 3. So and similarly C, a point C I'm taking, this is C and passing through the equation number 1. So equation number 1 passing through the C, then you will get 2 equal to L of 1 square plus m of 1 plus n, then you will get 2 equal to L plus m plus n. So by solving these three, you will get the L, m, n values. So solving 2 and 3, I'm taking 4L plus 2m plus n equal to minus 1, L minus m plus n equal to 1. Then you can take here 4L minus, this is minus, this is plus, this is minus. Then you will get, this is 3L, this is cancel. So you will get 2m plus m is 3m. This is minus, minus 1, minus 1, minus 1, minus 2. So then next, then 3L plus m, 3L plus 3m equal to minus 2. Then solving 3 and 4, you can get L minus m plus n equal to 1, L plus m plus n equal to 1. Then next you will get, so these two gets cancelled, L gets cancelled, n gets cancelled. This why? Because of this is minus, this is minus, this is minus, this is also minus. So this minus m, this is minus 2m, and 1 minus 2 is nothing but minus 1. So then this value minus 2m equal to minus 1. So then m equal to 1 by 2. So then next substitute m value in 5, equation number 5, then you will get the L value. 3L plus 3 of 1 by 2 equal to minus 2. Then just solve this one, 3L equal to minus 2 minus 3 by 2. So take LCM, then you will get minus 4 minus 3 by 2 is nothing but minus 7 by 2. L equal to minus 7 by 6. L equal to minus 7 by 6. Then next substitute LM values in any 3 equations. I'm taking in 3. So then I will get minus 7 by 6 minus 1 by 2 plus n equal to 1. Then minus 10 by 6 plus n equal to 1. Then I will get n equal to 1 plus 10 by 6, that is n equal to 16 by 6, that is nothing but n equal to 8 by 3. So we got the values of L, M, N. L, M, N. Then just substitute the values L, M, N in the equation 1. Then that is x equal to Ly square plus My plus N. So then just substitute x equal to minus 7 by 6 y square plus 1 by 2 of y plus 8 by 3 equal to, so that is x equal to minus, take LCM, minus 7y square plus 3y plus 16 by 6. Then you will get 6x equal to minus 7y square plus 3y plus 16. Then required equation is 7y square plus 6x minus 3y minus 16 equal to 0. This is the equal to 0. This is the finding the equation of the axis parallel to the x-axis. So which means a parabola passing through the 3 points and its axis is parallel to x-axis. Then we can find this in this way. So now we can solve another problem with respect to y. With respect to y, find the equation of the parabola. Find the equation of the parabola whose axis is parallel to y-axis. Whose axis is parallel to y-axis, which passes through the points 4 comma 5 minus 2 comma 11 minus 4 comma 21. So then similarly above problem, as usually here in the above problem, we take that x equal to Ly square plus My plus N, which is parallel to x-axis. Now in the y-axis means y equal to sorry, here y-axis, this is y-axis. So then y equal to Lx square plus My plus N is equation number 1, and it is passing through the 4 comma 5 minus 2 comma 11 minus 4 comma 21. So then equation number 1 passing through the 4 comma 5, equation number 1 passing through the 4 comma 5, then you have to substitute the 4 comma 5 in the equation number 1. Then you will get L of 4 square plus M of 4 plus N equal to 5. Then next 16L plus 4M plus N equal to 5. Equation number 1 passing through the minus 2 comma 11. So then you will get as L of minus 2 whole square plus M of minus 2 plus N equal to 11. Then 4L minus 2M plus N equal to 11. This is equation number 3. So equation number 1 passing through the minus 4 comma 21. Then L of minus 4 square plus M of minus 4 plus N equal to 21. Then you will get 16L minus 4M plus N equal to 21. So then this is equation number 4. We get the values of 2, 3, 4. So 5. So a parabola equation passing through the given 3 points and which is parallel to y-axis. So we get these 3 equations. From these 3 equations we can get the values of L, M, N. By solving 2, 3, 4, we can get L, M, N. So for that one, we are doing solving 2 and 3. Then 16L plus 4M plus N equal to 5 and 4L minus 2M plus N equal to 11. Just you have to do subtracting. Here you will get minus plus minus. So N will get cancelled. Then 16 minus 4L is nothing but 12L. 4 plus 2M is nothing but 4M plus 2M is nothing but 6M. That is 5 minus 6. 5 minus 11 is nothing but minus 6. Then 12L plus 6M equal to minus 6. 12L plus 6M equal to minus 6. Then I will get the value. As 2L plus M equal to minus 1. This is the equation number 5. This is equation number 5. Now solve 2 and 4. I am solving 2 and 4 for easy purpose. 16L plus 4M plus N equal to 5. And the next value is 16L minus 4M plus N equal to 20. So just you have to subtract this one. So this value is minus, this value is plus, this value is minus. Then these both are cancelled. 8M. You will get 8M minus 16. This is also minus 1. So then this is also minus 21. 8M equal to minus 16. Then M value. What you will get? M equal to minus 2. M equal to minus 2. This is the m value. So just you have to substitute the m value in the equation number 5. Then you will get substitute value m value in equation number 5. Then you will get what you will get. So 2l minus 2. 2l minus 2 equal to minus 1. Then L equal to 1 by 2. L equal to 1 by 2. Substitute L m values in 3. Then you will get 4L minus 2m plus 11 equal 11. Then 4 of 1 by 2 minus 2 of minus 2 plus n equal to 11. Then this is cancellation. This will go into cancel. This is 2 and 2 of minus 2. This is minus into minus plus. Then you will get 2 plus 4 plus n equal to 11. 2 plus 4 plus n equal to 11 means n equal to 11 minus 6, which means n equal to 5. So this value n equal to 5. So now next, so substitute lm values, lmn values in the required equation, that is nothing but y equal to lx square plus mx plus n. Then just you substitute L value as 1 by 2, m value as minus 2, n value as 5. Then take LCM. Then x square minus 4x plus 10 by 2 equal to y. That is nothing but 2y equal to x square minus 4x plus 10. Then x square minus 4x minus 2y plus 10 is the required equation. For given points. So here we discussed two types. That is, one is axis is parallel to x-axis and another one is parallel to y-axis, and a focal distance and the focal distance. These 3 points and the notations is there. And now you have to take, okay, 1 minute. You have to take one assignment here. So find the equation of the parabola. Find the equation of the parabola whose axis is parallel to x-axis and which is passing through the points, these 3. So what is asking here? So what is asking? Sorry, 1 minute. Okay. So here these points minus 2 comma 1 and 1 comma 2 minus 1 comma 3. Here what is saying that which is parallel to x-axis, which means x equal to L y square plus my plus n. Just you have to substitute this is the required equation. And this equation is passing through the minus 2 comma 1. Then you will get one equation. If passing through the 1 comma 2, you will get another equation. If passing through the minus 1 by 3, you will get another equation. So these 3 equations, these three equations, you have to solve for LMN. And after the finding of LMN, you have to substitute in the equation and simplify that one. That is the required parabola equation which you want. So this is the assignment for today. And next one. So this is parametrics. I will discuss after this one. So one problem is there. Sorry. So we'll discuss a parametric equations of the parabola. We can discuss now parametric equations of the parabola, which means, so parametric equations is nothing but if a point substitute, unknown point substitute in the equation, then you will get same equal points. That is nothing but you know the values of parametric equation in the circles. X equal to x1 plus r cos theta plus r minus r cos theta, y equal to y1 plus r minus sin theta r sin theta. So that's why similarly in the parabola also we have to take here at square comma 2at. Satisfy the equation y square equal to 4x. So with a point substitute in the parabola equation, this will be satisfies. That is nothing but the parametric equation, and also this is other proof also. So there is no need to prove here. Now we are taking at square comma 2at, then y square equal to 4x. This is satisfying. So parabola for all real values of t. Then if p x comma y is point, y square equal to 4x, a is greater than 0, then x equal to at square, then x equal to at square, y square equal to 4a of at square, 4a of at square. Then we get y equal to 280, y equal to 280, then r minus 280. So here substituted. Therefore p is the form of at square comma plus or minus 280 is nothing but 280. So then, so if we are taking in the first coordinate, this will be plus 280. If we are taking in the fourth coordinate, it will be minus 280. So hence the parametric equations of the parabola x equal to 80 square comma 280, the point 80 square comma 280 generally denoted by point p of t, point p of t. So for that one, this is the important. So first one, in the question, if the coordinates of the ends of the focal chord, if the coordinates of the ends of the focal chord of the parabola y square equal to 4x or x1 comma y1 and x2 comma y2, then prove that x1 x2 equal to a square, y1 y2 equal to minus 4a square. Just what is asking that focal chord, he given that the end points of the focal chord. Focal chord means, what is the focal chord? So focal chord means a chord is passing through the focus. A chord is passing through the focus. So that is nothing but focal chord. Okay. So and that endpoints are x1 comma y1, and that endpoints are x1 comma y1. This is x1 comma y1 and this is x2 comma y2. So this is 2. So x comma, then prove that x1 x2 equal to a, y1 y2 equal to minus 4a square. So x1 x2 equal to a square, y1 y2 equal to minus 4a square. Just you have to prove that one. Next, so for this one, so let p x1 comma y1, I'm taking what I am saying that parametric forms, parametric form, parametric point. So that is nothing but 80 square comma 280. So here I am taking 2 points, that is at1 comma 2at1, at1 comma 2at1 and at2 square comma 2at2. I am taking at1 square comma 2at1 and at2 square comma 2at2. Then these be two endpoints of the focal chord. P, S, Q are collinear. Here I am taking is P, first point P and second point Q. I mean endpoint of the that are to P and Q, and which is passing through S. Then these three are lies in the same line. These three are lies in the same line means P, S, Q are collinear. So collinear property means we have more than 4, I think. So for finding the, so how can we prove that the collinear? Collinear means slopes equal and delta value 0. So then that's why we can find. So I'm taking here only slope value. So that is slope of PS equal to slope of QS. So slope of PS equal to slope of QS. So then slope of PS, P and S, slope of P and S. So P value is the S value. S value. What is the value of S? Here what is given that a comma 0. This is a focus for y square equal 4x. Then so S and P, these two. So y2 minus y1 by x2 minus x1 is the slope of the given 2 points. That is nothing but y2 2a1 minus 0, 2a1 minus 0 and at1 square comma minus a, at1 square comma minus a. Similarly, these 2 points will get 2a2 by at2 square minus a. Then we'll get cancel, these two cancel, will get cancelled, and take also here a common. So this will get 1, this will get 1. So a also cancel. So then we'll get t1 by t1 square minus 1, t1 by t1 square minus 1 equal to t2 by t2 square minus 1, t2 square minus 1. Then next, sorry, so cross multiply t1 of t2 square minus 1 equal to t2 of t1 square minus 1. Then so solve this one, multiply t1 t2 square minus t1 equal to t2 t1 square minus t2. Then you will get, take into left side values, all values. Then t1 t2 square minus t1 minus t2 t1 square plus t2. then you will get this value as T1, T2. Take the common from these two. Take the common these two. You will get T1, T2 taking common. Then you will get T2 minus T, and minus here plus T2 minus T1, plus T2 minus T1. So from these both I'm taking this T2 minus T1 as common. Then I will get. Wait. So T2 minus T1. T2 minus T1 of T1 T2 plus 1 equal to 0. Then T1 equal to T2 minus T1 equal to 0. T1 T2 plus 1 equal to 0. Then we will get T2 equal to T1 and T1 T2 equal to minus 1. T1 T2 equal to minus 1. And what is the T1 T2? Just from 1 x1 x2. From the question, x1 x2 equal to, what is the x1 value? At1 square. What is the x2 value? At2 square. Just substitute the values here. Multiply this one, a into a square, T1 square, T2 square. I'm writing T1 T2 whole square, and we get the value of T1 T2 as minus 1. T1 T2 as minus 1. Just you have to substitute minus 1 whole square. That is nothing but x1 x2 equal to a square of minus 1 whole square equal to x1 x2 equal to a square. This is the first proof. And the second proof, just y1 y2 equal to 2a T1, 2a T2 equal to 4a square of T1 T2. Then just you have to substitute the T1 T2 value as minus 1. Then you will get minus 4a square. This is the required answer. And the next one is, so here conclude this, x1 x2 equal to a square, y1 y2 equal to minus 4a square. Then next, same problem on this one. So focal chord PQ of the parabola y square equal to 4x, SP equal to L, SQ equal to L dash. Then prove that SL 1 by L plus 1 by L dash equal to 1 by A. So what is taking there? So P be any point and Q be any other point. So these are in the parametrics. So then P is 81 square comma 281, Q is 82 square comma 282. We know the values of T1 T2 equal to here, T1 T2 equal to minus 1, T1 T2 equal to minus 1. So then from 1, so L equal to SP. Here what is given, that SP equal to L. So distance between S and P. So what is the S value? S is a focus. S is nothing but a comma 0. S is nothing but a comma 0. Just to find the distance between the 2 points, that is nothing but under root of x2 minus x1 whole square plus y2 minus y1 whole square. Just substitute the values. Then a T1 square minus a whole square plus 2a T1 minus 0 whole square. Then you will get, so expand. So a square is there. So in the both terms, you will get a as a getting into outside. Then you will get T1 square minus 1 whole square plus 4T1 square is nothing but, so this is in the form of a square, a minus b whole square, plus 4ab. This is in the form of a minus b whole square, plus 4ab, which means so here this is a square minus 2ab plus b square plus 4ab, which is nothing but a plus b whole square. This totally, this will be goes to a plus b whole square, So this is a plus b whole square. Similarly here, this value T1 square minus 1 whole square plus 4T1 square. This is expanded one. T1 square whole power 2 plus 1 minus 2T1 plus 4T1 square. 2T1 square plus 4T1 square. Then minus 2 plus 4 is nothing but plus 2. Then this is nothing but a of 1 plus T1 square. Next, substitute similarly L dash. So L dash. So this is L, and L dash, you have to find the L dash value. So this is L dash value substituted here. So here what it says that, so this is L dash, this value is L dash. So similarly you can find this one. This is AT, this is AT2, T2, T2. So T2. So then L minus A into L dash minus A. Then you will get L dash L into L minus A into L dash minus A. Then you will get A square into T1 square, T2 square. That is nothing but this value. We know the value of -1. This is 312 is nothing but -1 in the previous problem. So there is nothing but A square. So from that one, so I'm taking, so L dash, multiply this one, L dash minus A, L minus A L dash plus A square equal to A square. L dash minus A plus L dash equal to 0. Just solve this one. So you will get 1 by L plus 1 by L dash equal to 1 by A, equal to 1 by A. So once again, I'm repeating this one as here L equal to SP and L equal to S dash SQ. This is SQ. So here AT2 square, sorry, here this value. So L minus A, L dash minus A. I have to take that one. So for this one, this is SQ, S dash Q or SQ. So then this will be different. So then you will get value and multiply these two. You will get A square into T1 square, T2 square. Multiply these two, you will get this value and substitute the value of T1, T2 equal to -1. Then left hand side also expansion. Then you will get this one, and then lastly we get required answer 1 by L plus 1 by L dash equal to 1 by A. Okay. Thank you, students. Thank you, one and all. Thank you, madam.
Thank you,
Hello.
sir.
Okay.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, madam.
Okay, right, ma'am. Thank you, sir.